Hello there guys, and welcome back to another epic inexorable maths video. In this video we're taking our first look at limits. What is a limit? That's a really strange thing. You may have seen it before, but we want to formalize it. We want to actually talk about what these things really are. So if you've done a little bit of differentiation or calculus in general, you may have seen a formula. The formula says that the derivative of a function, we call it f prime of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h, right? And that's all well and good, it's fine. But what is this thing doing right here? This limit as h approaches 0. What is that? If you haven't seen this formula, by the way, don't worry about it. It's fine. This is just an example of where you might see a limit. Now, with a lot of functions, we know how to evaluate this limit, right? Because if your f of x is x squared, we simply substitute x squared into this formula, and we end up getting the derivative of x squared is 2x. The issue is, though, and the reason why this limit has to be here in the first place is because in order to do our differentiation, h has to be 0, or it has to be infinitely close to 0, and you're not allowed to divide by 0. So it's very difficult without a limit to be able to express what you're doing mathematically. So limits are really, really important. In future videos, we will talk more about how we can evaluate different limits, because there's lots of different methods to figure out what different limits are. But in this video, I want to just have a look at some rules of limits and look at the formalities. Look at all of the, the formalities, the rules of how limits actually work. Okay, so that's what we're going to do today. And we're just looking down here. So we can call this limit algebra. It's just the algebra of limits. So what is a limit? As I said, a limit is simply this thing where we are approaching some constant. It doesn't always have to be 0. It can be a constant a, or it can be infinity. It can be anything that you want. It can be a negative number, a fraction. We can approach any number, but we have some rules. And actually, these aren't too bad. They're kind of exactly what you'd expect them to be, almost. But let's have a look at them either way. So first of all, let's just define two limits. The first limit is, we're going to say that the limit as x approaches a, where a is just a constant, it could be 0, it could be anything, of f of x, we're going to say that that's equal to L. So that is equal to L. And L is just some function, it's a constant, doesn't really matter what it is, it's just something. It's normally going to be a constant. And we're also going to define another limit. We're going to say that the limit as x approaches the same thing as x approaches a, as x gets infinitely close to a without actually ever reaching a, of this other function g of x, we're going to say that that's just equal to capital M. Okay? Now, there's 4 rules that we need to know. They're all written here. The first one is simply that the limit as x approaches a of the sum of our f of x and g of x is just the sum of the limits, okay? So the limit of the sum is the sum of the limits, okay? The second one is the limit as x approaches a of f of x times g of x is L times M, okay? Which basically means the limit of the product is the product of the limits. Not too bad. Again, it's what you'd expect, right? You take the limit of two things times together, you get the limit of two things times together. Or you get two things timesing together with their own limits. The third one, as x approaches a of the quotient of f of x and g of x, so f of x divided by g of x, this is just equal to L divided by M. So the limit as f of x as x approaches a of f of x is L, the limit as x approaches a of g of x is M, and the limit as x approaches a of f of x divided by g of x is simply going to be L divided by M, provided that M is not equal to 0, of course, because we can't divide by 0. And this just says that the quotient, or the limit of the quotient, is equal to the quotient of the limits. Amazing. And finally, we have this last rule here, which says that the limit as x approaches a of k times f of x, where k is a constant, is equal to k times L. This basically just means you can factor constants out of limits. So if you're taking the limit of 5 times something, then that is just 5 times the limit. So you can just take the 5 out and times by it at the end. Constants essentially don't change the value of limits other than just multiplying that limit by the constant. They don't actually do anything else. They don't affect the limit in any other way other than just scaling it by the value of the constant. That's all it is. So in the next video, what we will do is we will look at one method to find limits and looking at different limits, because this is it's the first video. It's kind of a formality almost. It's just showing, these are the rules. Let's just know the rules. But really, we need to actually look at some problems in order to fully grasp this concept. So that's what we'll do in the next video. We'll look at what different limits are and how we can evaluate them. And the different methods to do that. Awesome. Thank you guys so much for watching. I highly appreciate it. And I'll see you in the next video. Cheers.